Hello and welcome once again to the AI Galaxy. And my name is Oleg, and I'll be guiding you through today's episode. We are here very, very happy and very excited to have an excellent external guest this time. And we're going to talk about running local models for your AI tasks, how you can optimize that, what are they good for, should you even bother? So please welcome in our studio is Avanika Narayan, and she is an absolutely brilliant AI engineer, a co-founder for Rocks, and one of the main author, the first author of the Minions paper, which appeared and got published a few months ago, several months ago, which is a long time in AI universe, but we're going to talk about super exciting development. Recently, the Minions protocol has been integrated into Docker AI products, and we are here to look at the demos, learn what Minions are, and just in general increase our knowledge about local LLMs. Hi, Avanika, how are you doing?
I'm doing well. Oleg, thank you so much for having me. It's been a pleasure working with all you guys at Docker, and so being on the podcast now is kind of full circle moment. So thank you.
It's wonderful to have you here. I personally have a lot of questions about both the implementations of Minions and what are the implications in like how do you see that and where this is all going. So before we start, right? So there is this. Most of the people, most of the developers had their ChatGPT experience, right? There is a plenty of managed AI solutions where you can just go and send the chat message to a remote AI managed by like a giant data center, and it will come back to you with an incredible amount of information on any topic, write code for you, create business plans for you, create marketing campaigns, generate images, videos, whatever, right? We are super, super privileged to live in the age where that is possible, and also where that is fairly cheap, heavily subsidized probably. But there is also local AI, right? You can run AI components locally. In my experience, not a lot of people do that, right? If you go on any forum online on Reddit, if you hang out in Discords, people do not run local models. Do you think, and what's your point of view on that? Is it just, is it going to get better? Is it not the time yet? What is happening? Are they just too weak and too slow?
Yeah, no, I think that's a great question. So kind of like the way I view this, and a lot of the motivation for our work was we saw kind of two primary trends. One, this notion of compression of intelligence. And so what that means is you're getting smaller models that are a lot more capable. So for example, the 3 billion parameter models of today that can fit on your laptop, they have roughly the same capabilities of, say, one of the large frontier models from kind of like, a year ago. And so that's like one thing, which is like this notion of like compression of intelligence. And then number two, this hardware is getting a lot better. So I have basically the equivalent of like a pretty strong GPU on my Mac right now, and I can be running models that are quite large, like billions of parameters. And so because of these two trends, like we now have the capability to run super strong models locally. And I think a lot of people just don't know that. And it's almost this kind of piece of like, they haven't tried it, so they don't know. But there's so many new like vehicles, whether that be Minions or things like Llama, Docker model, which are making it more accessible and easier to actually run these things on device. And so I really think it's a matter of just getting the community to know about these opportunities and the fact that you actually can run a large amount of your workloads on device. And I just think right now people just don't know that. So.
Right. I agree with the sentiment that models now, local models, are so much better than before. And I recently saw that Qwen, something like 4 billion parameter models for Qwen, are on the same level as ChatGPT 3.5, right? And then back then, 3.5 was, it was 2 years ago, I think, around 2 years ago, but it was a wow moment. Absolutely. We were super excited. We were like, oh, we're going to build so many amazing things with this technology. And now we have that and are able to run it locally, but it's not exciting enough for us because state of the art for the managed models for the cloud solutions run so much further. Do you think it's going to stay this way, or do you think the managed model will plateau first before the local models?
Yeah, no, I think the way to think about this is that it's not really a zero-sum game. Like you run things locally or you run things in the cloud. I think the way that we want to think about it is you actually have two compute resources. You have local compute, you have cloud compute. You kind of want to get the best of both worlds. Like in the most ideal scenario, you actually have these things collaborating and working together. So when you have certain use cases where you actually want to run things locally, you can do that. When you have certain use cases where the task is just frankly too complex to be run locally, you'll run it in the cloud. And then there are, of course, these like hybrid workloads, which can utilize both cloud and local compute. And that I think was kind of like the main motivation behind Minions and thinking about how do we actually bridge both worlds and bring frontier level reasoning to your device without just like feeling like you're boxed into either one of those solutions. I personally don't hope we ever plateau in any way, shape, or form. So yeah, that's kind of my intuition. We kind of want to think about this as a positive sum game.
Right. That is awesome, and that also leads us directly to the Minions practical and to the sort of the main demo and like physical things that we can look at for this episode. Can you explain what the Minions protocol is? And for people who know why there are like a singular minion and the plural minions, and what do you think this Minions approach is great for?
Yeah. So the kind of high level TLDR of what Minions is it's a way for hybrid collaboration between on device LLMs and frontier cloud models. And the top level result that we were able to show was that we were able to kind of have massive cost reductions by letting these two models collaborate on complex tasks. And so this was, just to summarize it, a 6x cost reduction while maintaining 90% accuracy of just using a frontier model alone. And so what exactly is the protocol? So the way to think about the protocol is you have some cloud model orchestrating a local model to conduct a task. And critically, all the data that is necessary for the task stays local. And so this is super important for things like privacy. Say you have a bunch of, personal documents on your laptop that you don't feel comfortable sharing with the cloud. You can use this protocol to actually keep those documents on your device, but complete the tasks that you care about. And so we have two main protocols. One is called Minion, and then Minions plural. And so Minion is, the way to think about this is you have one instance of a local model and one cloud model. And these two things just kind of like chat and go back and forth in order to solve the problem. In terms of Minions, this is more of kind of like, the way to think about this is slightly in like a multi-agent setting where you have one cloud model and it's orchestrating many instances of a local model. And so again, it's the same sort of back and forth protocol where they're working together on this task. But when it's time for the work to be done locally on device, that's basically partitioned across many instances of a local model. So you're doing a bunch of parallel work. And so why is that important? Think about having to do like large document processing or refactoring of code bases where there's millions and millions of tokens. You want to be doing that in parallel in order to kind of get that time to completion down. And so those are like the two protocols there, if that's helpful.
Right. So in a nutshell, they're going to be the cloud model that is the brains of the operation. It's going to give the tasks, so it's going to prompt the local models to achieve certain tasks. And the cloud model will not actually see the data that we want to sort of process during the task, but it will receive a description of that data, and then we'll be like, okay, we're working on a document. This is how you chunk it. Take the page, find information on the page, go further, right?
Yeah.
Is that
exactly right? Yep.
Awesome. So in the most direct application, this is sort of like a remote LLM orchestrated RAG pattern. And I'm sure you can do more with more complex things, but the basic there is. So instead of just a simple like embedding and similarity search, your local LLM gets an actual prompt and can do whatever the orchestrator requires. That is awesome. Let me share my screen. I have an example because recently the Docker model runner got the capability of running Minions as the protocol. And I have here my, let me just make zoom slightly higher. I can run the Minions Docker example, right? Following the Docker's paradigm for orchestrating AI workloads using Compose, this is what we have, right? This currently is the Minions repository, and the example is from the Minions repository. I just have the compute power on my machine to run this locally. I'm going to use, for the local model, I'm going to use the Qwen-3 mixture of expert model. It's fairly capable. It's very recent. It's very, very good at a decent quant, so it's not even too dumb as it goes, with the context size of like a reasonably sized context, right? We will build the Minion server, which is the background, which will be able to query our OpenAI. And so here I have the Minions configuration, right? Can you explain things like what are the rounds, what are jobs, and what are tasks in terms of Minions?
So the way I think about the rounds is this concept that I introduced earlier, which is one round would be the cloud model telling the local model what to do. And so that's considered one round of communication and one round of work. And so we enable the user to actually configure the max number of rounds. So say you want to enable these things to spin for an hour, you might set that number to be quite high. Say you want an answer super fast, you'll set that number to be something that's smaller, maybe 3 or 2 or so on and so forth. In terms of jobs per round, so this gets back to this notion of how many actual like sub workers do I want to spawn on a particular round. Again, like that's something that can be configurable and tuned. And then tasks per round would be, so each like, you know, sub agent or sub module can be given a number of subtasks for that particular round. And so that's what that task parameter is.
Right. Okay. So this is the way to chunk the work and give commands to this smaller local LLM.
Yes.
Okay. So very good. We can configure a Minions protocol using those numbers. They're going to get into the actual code for the Minion server. And we're going to have also here in this Compose, we're going to have the front end, our application that we're going to use to actually give our system a sample query. And this front end will also give us some metrics about the execution. So I have a question from Max. How easy is to measure remote model cost reduction? I don't think, like, is it something that Minions protocol does by default, or is it something that we need to monitor on the sort of the front end side?
Yeah, so by default, the Minions protocol will report the difference in tokens used by the local model and the remote model. And then, of course, like cost dollar by dollar is dependent on the provider.
Yeah.
And so you would have to do that like calculation yourself.
Okay. Yeah, this is fairly trivial to do on your side. I'm going to run this Docker Compose, right? It's going to spin up everything for me. And let's go and see what I can do now with our workers. So if I go to the browser, I refresh this page. This is our front end from that example. We're gonna give it some data first and for all. We're gonna upload the Minions paper, which is 8 meg PDF. The front end here is gonna transform that to text, because, well, small models mostly work on text, right? They are large language models for a reason. We are not using any visual or video processing models. So this will be the text that is chunked, and local LLM will query that. Now we need to describe this, right? I'm going to describe this as a research paper. And I'm gonna say the task for this. We're gonna say, find in this data set what are the 3 evaluation data sets were used, right? So this is our main question. This is our data, and we're gonna use the Minions protocol, and we are not gonna configure anything, and we can just click start. Right? So now what happens behind the scenes? Can you narrate sort of what is supposed to happen?
Absolutely. So kind of what happens behind the scenes. This task, what you're gonna see is the actual query that was made by the user is passed up to the remote model. The remote model is going to specify a set of subtasks that are to be computed locally. That's passed down to the local models. And that is executed locally. The work done by the local model is sent back up. And if the remote model feels like it has sufficient information to answer the task or to provide an answer for the task, it will do so. If it doesn't have the sufficient information it needs, it'll send down another round of subtasks. But in this case, it seems like it's already done. And you can kind of see the beautiful things in terms of, token reduction, the actual amount of time it took, so on and so forth. And we do get the correct answer here, which is Finance Bench, Long Health, and Casper, which were the evaluation data sets used in the paper.
Right. Okay, so let me take this screenshot of this. Right now they run the Minions protocol. It ran a little bit more than half a minute, and it used. We don't count local tokens, right? Local tokens are free. I'm running this on my machine. Well, I guess I am paying something for the electricity, but this is negligible, right? This is just a MacBook, so it's not a data center. It's not an external GPU. I'm in a hotel room, so technically I'm not paying for electricity directly as well, right? So we have 7,000 remote tokens. This is the tokens that were sent as a prompt and output tokens from the remote LLM, right? So if I do the same, and if I select just remote model only, we can do the comparison, right? Here, instead of using the Minions protocol, we're gonna just send everything to the remote model. I hope this works. I do have my OpenAI key configured as a variable. Okay, so with the remote only, it's much, much faster. It gives us a longer answer with some explanations, and it uses also 30,000 remote tokens. It was 7,000 before?
Yeah, that was
right. So it's like 1/5, a little bit more than 1/5. So 80% reduction. Not bad. The execution time is, of course, unparalleled, right? We don't compare the local model execution. Perhaps it could be better. It could be faster, but there are privacy concerns, right? Like, we are sending data here to OpenAI, which sometimes we cannot technically do with whole our data. Right. Okay, so it used one round. It quickly found the answer. Do you think it could be educational to tweak any of the parameters in the compose file to see a different execution, or that is not something that is very educational?
I don't think it's very educational for this example. So
okay. So the examples are merged into the public repositories. They are available on the Minions GitHub repository. It is also merged into the Docker's Compose for Agents repository, so you can just run it. Docker desktop recent versions support the Minions protocol out of the box. So if you are just running this example, it will run properly the way you saw me running it just now. So you can try that. You can try with different tasks. You can see how it works for you and your scenarios. So when we talk about Minions, what was the sort of the moment? What was the main motivation for doing this? Did you think? So we have like cost, we have privacy, and we also have sort of the potential latency, which is not solved yet, but you can parallelize the execution, and technically you can get latency gains as well. Why did you do Minions?
Yeah, so we were kind of motivated by these very like data intensive processing tasks that we envisioned happening like locally on device. So kind of the things that I mentioned earlier, where you have some large code base and you want to be running these like always on processes, for example, like bug finding 24/7. Or say you have a bunch of, papers, you're writing a bunch of essays and you want to have some sort of like paper writing refactor happening like overnight, right? And so this is something that has to be done locally. And because of cost reasons, it's prohibitive to just be doing this in the cloud, right? And so we thought, okay, like, why don't we just try running these small models on, these document processing tasks, on these code like bug finding tasks, on these like medical document parsing tasks. And we did it. We gave it a go. And kind of like just using the local models alone, we realized was a no-op. Like the models kind of struggled with two main things. One, they just can't fundamentally handle long context, despite the fact that they are advertised to be able to process 128K tokens, so on and so forth. And then two, they just really can't do complex tasks. And so that kind of led to this insight of, okay, we need to do two things. We need to effectively chunk or partition the context in order to let these small models be efficient. And then number two, we need some way of giving them small bite-sized tasks that they can do. And we're like, okay, what is the best way to actually do this orchestration? We obviously as humans can't orchestrate this thing every single time we want a task to be run, because then we wouldn't have that always on behavior. And so that's when we came up with this intuition of, let's actually have like a cloud model which can dynamically allocate work to these smaller models without actually having to see the local files, but just has some general knowledge of what the task actually is. And so that was the motivation for us. Like the real motivation was wanting to do these like large data processing / analysis tasks on device. And this was the best kind of like solution we came up with.
Yeah. How would you compare this to like normal agent orchestration approaches?
Yeah. So I think the real key thing here is like this asymmetry, where you have a significantly weaker model that's working with the actual data and touching the actual data. That's one piece. The other piece is this asymmetry in information. In most multi-agent setups, every single agent has access to the same information. But here, because of this like kind of like privacy constraint and wanting to keep things local, one of the model, namely like that orchestrator model, is kind of like running blind. And so that those are in my mind kind of the two differences. One, it's this asymmetry in capabilities, and then asymmetry in information.
That's a good way to think about this. When you talk about privacy, right? Would you, if I understand correctly, it's not completely private,
Yeah.
right? We still do send some information to the actual orchestrating LLM, both to describe the information that we process, and also to outline the responses. So, like, it's not an air-gapped local environment. And like, would you also expect that a sort of a malicious LLM could just task to send data to itself?
Yeah. So you are absolutely right. It's not fully air gapped. We do have modes in the Minions protocol, which enables you to, at the very least, like make sure that no PII is sent up. And so if you are worried about, say, sending things like, your birthday or like names, you can actually filter that out. Or you can, we do have like a layer that enables you to filter out that information before it gets passed up. But I do agree that there are probably some, there's definitely ways to jailbreak this thing. And if it's of like concern to some developer and this is like a use case that they really want, we'd be more than happy to figure out a way to implement that and kind of support that use case. So
Right. So you're saying that the work on Minions continues and the project doesn't, it's not like an implemented solution. This is the active area of research and this moves forward.
absolutely. Yep.
What are the roadmap, if you can share, what are the roadmap items that you're working on?
Totally. So we actually just took a first pass at what we call Minion Secure, which we think is super interesting. And there's a whole blog post on this. I can link it in the notes. And the idea there is, we're very concerned about like kind of the privacy of the cloud model, right? So that's like the primary point of leakage here. And so what Minion Secure did was we demonstrated a proof of concept for actually running one of these larger language models in a trusted execution environment. And so a trusted execution environment ensures that any information that is passed from the CPU to the GPU is actually encrypted. So if you were to, set up a GPU in a cloud provider that was running in one of these trusted executed environments and working with a local Minions model, that would be an end-to-end secure pipeline.
Yeah.
And that's been kind of our first initial pass here. And a lot more developments are coming through. So
this is awesome. From the way you describe this, it feels like there is quite a bit of complexity, right? It like the basic idea you explained it in a couple of sentences, right? Like it's very clear, but the implementation details, even this in this sample compose example, like there were a bunch of parameters to tweak. There is also things like the model choice. Do you think Minions could become, or the technology based on Minions, like the next iteration, could become sort of a like an individual developer, like a thing in their toolbox, or is this the sort of the enterprise solution where an actual team that understands what they're doing needs to configure this for a particular task, like I don't know, processing medicine data or doing something with other private data? What's the positioning?
I think it's honestly both. I think from the developer standpoint, it's a great way to build with cost reduction in mind and other constraints in mind. So one constraint is obviously cost. Another constraint could definitely be things like, what models can you actually run on your device and what are you constrained by in terms of memory, energy, so on and so forth. And then, of course, there is obviously the enterprise use case, which is super valuable. And we've seen a lot of interest there where folks are really cognizant about this interplay of what data they're sending to these cloud providers and at the same time, want to have, the latest and greatest reasoning capabilities in their environments. And so, yeah, to your point, like doing these very enterprise-specific deployments, whether that be in medicine, whether that be in financial institutions, is definitely something where we see this going.
That's awesome. All in all, Minions is not about just replacing the big models or paying less money for them, right? It's about augmenting the workflows where the cloud AI is not the best solution. If you would have a couple of sentences takeaways, how do you want people to think about Minions, and what would be an actual step that you would recommend them taking to learn more about this?
Yeah, so I think the kind of overall takeaway is use Minions if you want to run more locally and you don't want to sacrifice accuracy and performance. And then in terms of advice, My advice would be just give it a try. It's very simple. Just go to the examples on the Docker website, and just start using it. I think you'd be very surprised to see how much you can actually save, how much you can actually do with this protocol, and yeah, don't feel like you're kind of boxed into just using these frontier models for everything, because that isn't our reality and that won't be our lived reality. We live in a world where intelligence is becoming more diffused, hardware is becoming more heterogeneous, right? We can run these models anywhere and we should be running them anywhere. So yeah, just please give it a go.
Right. What would be your sort of rule of thumb? What's the smallest models that actually are remotely capable of something? So like below which you wouldn't recommend trying with minions, because I can take the latest Gemma 3 model, which is like 200 something millions of parameters, and it will probably be not enough for the tasks that they throw at it. What would be your kind of sort of experience-based order there?
Yeah, so in my experience, if you're using anything locally that's 8 billion parameters and above, this should work perfectly for you. 3 billion parameters is, you get like a nicer kind of speed up, but sometimes struggles. So I'd say 8 billion is where like we see these local capabilities turn on.
Awesome. Are you talking about sort of dense models, or are we talking about mixture of experts as well, kind of sort of being capable enough?
Yeah, so I've mainly been experimenting with dense models. So I can't really speak to the smaller MOEs right now. But I would heavily advise like, dense 8 billion will get you there. Yeah.
Yeah, that very roughly mirrors my experience and my experiments as well. So even though I'm in no position to call myself an expert, I would recommend the audience to try dense models for 8, 12 billion, depending on how much you can run. Thank you very much. This was very educational. I enjoyed talking to you, Sanki. Thank you for joining. If we have any questions from the audience, now is the right time to kind of send them in the chat. And we are going to continue with the series. So while we are receiving feedback that this was a great episode, thank you, Brandon. Thank you very much. We're going to continue with external guests and also Docker engineers to talk about AI products and initiatives that are happening both at Docker and the ecosystem. Please do try Minions. The examples are available. Read the paper. It's 8 megabytes. It's not that bad. If a local model can handle it, you can definitely handle it. Just give it a go. It is very, very interesting. I think in the long run, local models are the way to it's a very interesting bet in terms of the ecosystem, right? Owning your AI, making sure that it doesn't change under your feet randomly, having the privacy concerns addressed. Those are very, very good things, and eventually we're going to figure it out as an ecosystem. Until then, stay tuned and see you in the next 2 weeks with another episode of AI Guide to the Galaxy.
Awesome. Thank you.
Thank you, Avanika.